Hi, welcome back to video demo 2.4. So in this video, I'm going to show you how are we going to construct the full product life cycle of the wooden shade. So in this video, we are going to link the wood plank that we have created, the production of wood plank that we have created, and we are going to link also the waste disposal method, which is open fire inert landfill created, and then we are going to link it to the blue color one, which is the life cycle of shade. So after we link this, then we are going to run some analysis, and then want to see the result. All right, and then after that, you are free to explore more analysis method on your own, assessment method on your own. Okay, so to link this product, so in SIMA Pro, you have to go to the product stages. Just now in video 2.2, 2.3, we are focusing more on this button processes. So we are playing with all these. So to link them together, so we have to go to product stages. If you observe, there are a few subcategories, subfolders of product stages, which are assembly, life cycle, disposal scenario, and disassembly and reuse. So here we normally will focus on these three folders, which is assembly, life cycle, and the disposable scenario. Okay, so assembly, like what you understand, it is assembly means uh, from raw extraction up to the user stages. Okay, so now we have to create the assembly for this wood shade. So let's look at the product. So on the assembly, okay, we are going to connect our wood plank, which is 150 kg, to produce one shade, and then a nail made from steel, which is 2 kg. Of course, this we do not have primary data, so we will rely on secondary data for it, and then we will link them together, and then we also will include the transportation of passenger car to bring this wood shade to the house. So this is the assembly part. All right. So the assembly part, let me highlight. So the assembly part will be this one. Okay. So we are going to link all these together. Okay, because this we already created, this one we already created. So we need to rely on the secondary data, and then we will input the transportation of it, which is 10 kilometer. Okay, so now we are going straight to the assembly. So on the assembly, I click on the folder of assembly. Okay, and then I click on others. There is nothing here, so I'm going to create a new one. So when I create a new one, there is input output tables, and then you will find out that the input output tables here are actually very much different from the previous input output table that you see from the processes and also from the waste treatment and waste scenario. So here we are going to name it. Okay, so we got it a simple wooden shade. All right, so we name our product simple wooden shade. So the material here, we know that it needs a plank of 150 kg. So we have to model it from our material. So if you notice that it comes from assembly or materials only. So you cannot put in energy into it, you cannot put transportation into it. So material, because just now in video 2.1, we have already created the process of wood plank under the wood. So this is the plank, which is what we need. So we select the plank, we select it, and then it is to put a 1 unit, okay, of simple wood shed. It is 150 kg of plank. So I just put 150 kg. Second things, we need the nails. Okay, so we'll create it. And then because, like I say, I do not have primary data about it, So we have to find from our library source. So in this case, I think I will browse through, see where we got it. Let's see whether construction we have. Okay, there's nothing about metal. So I will go and try out with the metal. So metal, there are ferrous, so and non-ferrous. So let's try alloy, see if we have anything here. All right, so let's say on ferrous, steel, iron casted, and then hot dip roll, steel plate, rebar. So there are a lot of we call it choices. So I will go and see non-ferro, see whether we got anything there. So we have aluminium, noid, so metal, zinc metal composite, lead byproduct. So I couldn't find any specific. So I couldn't find any specific. I couldn't find any specific uh, steel for nails. So I will just choose the most appropriate one. So I think I will see which one we can get near rebar sales section. 15 page. Okay, maybe I will choose steel wire rod for nail, something like that. So of course you can choose many other things. All right. Okay, maybe I'll choose. Okay, steel rod, wire rod Asia. Okay, something like that. So I'll choose this one, and then I'll put 2 kg in it. Okay, so I got this already. So another things that I have to put is the transportation, because inside our system boundary, we say that passengers or a consumer normally travel about 10 kilometer, okay, to bring the shade back home. Okay, so in here, we are going to put it under the processes. We cannot put it under material because they do not allow us to model transport in this category. So for processes, if you click on it, there are a few categories, which is energy, transport, processing. So we'll go to transport, and then of course it's by road. We see any passenger transport or not. So transport passengers, car. Okay, transport passenger car. So gasoline powered, diesel powered, motorcycle, home. So let's see what we have some more. Transport, school bus, single unit truck, transit bus. All right, let's see what we have. So if we have nothing to choose, then we will choose this one. All right, so just now we saw there is passenger car, and then diesel powered, gasoline powered. So there's no petrol, so we can only choose gasoline. So I think we will choose this transport passenger car gasoline powered. Okay, so put it here in and then select. And then if you see the unit, it is person kilometer. So person kilometer, normally, like I said, there are 10 kilometer, and normally there's one person who go and buy and then bring it back. So I will put 1 times 10 kilometer, which is 10. One person times 10 kilometer, so it is 10 person kilometer. Okay, so once I got it already, of course you can feel free to put in image. So I can put in anything here. You can import image, you can put a new image in. So let's say I simply choose one image here, then select. So this image will came out. All right, so I close it and I will save it. So now I have assembled one simple wooden shade already. Okay, so the next thing is I have to find the life cycle rate. Why we have different stages of assembly life cycle? If let's say your objective is to analyze the whole life cycle, and the assembly part is not your concern, actually you do not need to put it in model this process. Because this process is just to tell you that this is the simple wooden shade scope until it's like from cradle to gate. Okay, so for life cycle, if we see it, now we are going to create a life cycle of the shade. Okay, means we have the waste disposal and also the assembly. Okay, so here we will try life cycle of simple shade, wooden shade, which include the assembly. So assembly we already created already. So when I click on it, it will enable me to choose the one that I have already created in the assembly. So when I create it, so P is unit, so I just put 1 unit. So when I click 1 unit means everything is referring to 1 unit of it. Okay, so 1 unit. And then for processes, there is not much processes anymore during the using of this wooden shade. There is no electricity needed. There is no other things needed. Let's check for processes what we can put it in. We can put it energy, transport, processing, and use. So for use, basically there is no other processes lah. So for different from coffee machine, if coffee machine, we know that during the use phase, in total, how many kilowatt hour has been used for the lifetime of 5 years. But for wooden shade, because there is no energy or water needed, so we'll just leave it blank. So now is on the disposal scenario. So we have our scenario already. Waste scenario, if you still remember, in the video 2.2 and 2.3, we have created 3 scenarios. Scenario 2, which is 100% open fire, scenario 1, which is 100% open fire, and also scenario 3, which is co-disposal of wooden shade, which consists of 40% open fire and 16% landfill. So in this case, let's choose this one, a mixture of this. Okay, so here it is. So the waste disposal, I'll choose this disposal. So additional life cycle, okay, no other life cycle. If you have created another life cycle, you actually can combine this life cycle to another life cycle. But because there is no other life cycles here, so we'll just create this one. Okay, so now basically let's review what we have done for this life cycle. We are actually connecting the assembly and the waste disposal to the blue color things. All right, so this is what we are doing. Okay, in this page we are creating a life cycle of the shade, and then we connect simple wood shade, okay, to it, and then we connect the waste disposal number 3, scenario number 3 to it, okay, which is a combination of 40 to 60%. Okay, so when I close it, so now I have this ready. So basically, once I'm completed with this, basically we have finished modeling the we call it life cycle or processes or the flow diagram. Okay, so now next we it doesn't mean that you cannot change anymore. In future, you still are free. You are free to create new more process, change the information inside. Okay, if let's say I want to change the the waste disposal to scenario 1, so what do? You do not need to create a new one. You can click on it, okay, and then you can click this one and choose scenario 1 that you want. Once you choose that everything is okay, then you can just save it. Okay, let's say if I want to compare between scenario, okay, like I have scenario 1, which is disposal from the life cycle point of view, the disposal, and then another one is open fire, and then another one is mixture. I can create 3. Okay, how do I create? I click on it. Do you see the copy button? When I have a copy button, all right, so I will put it as I choose number 2, incineration. Okay, and then I will have this. So he said the same name have already exist. So you will put it at with 100% open fire, open burning, burn. something like that. Okay, so it limit your name. So I have two already. So the first one that I created is 100% landfill, right? So I'll create the name with 100% landfill. Okay, so now I have created two life cycle. One is 100% burn, one is the landfill. So I can create another one which is a core disposal. So I click on it. I do not need to recreate a new one. I just copy, okay, and then I just need to change. When you copy, everything will be the same. So you just need to change whatever you want to change. So from the waste scenario, I change it to the third one, co-disposal of wooden sheet. So I have to change the name so that I can save with 4060. Okay, I just put that so everyone understand. So in here, so I will close it, and then he will give me a. So now I have created three life cycle of simple wood sheet with different waste treatment uh, procedure, something like that. Okay, so now what I can do is I can start analyzing already. Like I mentioned in the class, analyzing or interpretation does not necessarily come at the last stage. You can start analyzing when you are creating processes of the felt tree, when you are creating the processes of sawmill, you can start analyzing already. But I do not want to do analyzing that because it will confuse you. So I will do in this training video, I will do the analyzing at the later stage. Okay, so now I'm going to analyze between these three. All right, so to save time, I just do a comparison. Okay, so I click these three together, and then do you see that there is a compare button here? You put on compare. All right, now is a choice of method. You have already know that there are midpoint and endpoint methods. So in this case, there are also multi issue and single issue methods. So let's say we start with something simple. We start with a single issue method, which a lot of people are very interested, which is the carbon footprint. So let's start with something single issue. So to choose, what I do is I double click on the method, double click, and then I'll choose single issue. So single issue, there are IPCC, there are greenhouse protocol, something like that. So let's choose IPCC GWP 100 years. Okay, so it gives you a very straightforward answer. So in this case, the rest, exclude infrastructure process, exclude long-term management, we'll just leave it blank. Then we start calculating. All right, so this may take a little bit of time. Okay, so I will need to wait. I couldn't see, couldn't fast forward it. So we'll just leave it running. So you can actually fast forward the video to see the result. So I have to uh, leave it until it is 100% done. Okay. Okay, so after a long wait, finally we have our we call it our result already. So we are comparing between three scenario: life cycle of simple wooden shade, 100% burning, 100% landfill, 100 and then the mixture of 40/60. So in this case, the impact to the environment is actually least for open burning. So open burning, they only create 19.4 kg CO2 equivalent. For life cycle of one unit of simple wood shade is 105. And then if this is a mixture of 40% to landfill, 60% to landfill and 40% open burning is 70.5. So we can actually see it from a chart. So in this case, we know that open burning is better. All right. Okay. Of course, this couldn't give you a very comprehensive picture because some of the activities of landfill are not included. And for open burning, also some compound are not included. We only include common compound chemical substances that we can get. All right. So it just gives you an idea of how the life cycle of a product can be we call it calculated by using SIMA Pro software. So in this case here, so in inventory, so it tells you that, okay, these are the substances, okay, from these three, we call it these three uh, life cycle. For process contribution, so it can tell you that these are the process contribution. So, and you can also check on the network, but now you couldn't check when you're comparing. So let's check one network which 100% burning. So let's see what you can get if you are checking on the network of one life cycle for 100% burning. Okay, so after a long wait, so now the network can be viewed. So you see, this is the network and it's not all can be seen yet. So the life cycle of simple wood shade, so a wood shade and the plank and the felt tree and the chainsaw and all of this. Okay, so the cutoff is 38.4%. If I reduce it further, let's say I put it at 0.5%, So you will see it is actually a very, very, very complex network. Okay, there are a lot of things there. Very, very complex network. All right. So just to tell you that what you can do. Okay. So all this actually you can export. All right. So to export your diagram, so what you can do is, let's say I put it as 10%. Okay. To export this diagram, so you open this page, then what you need to do is, okay, see, this one is show you input output tables. So you just put export. When you stay at this page on the file, there's an export. You just export it, and then you just save it somewhere. Let's say in the desktop, you put it network for simple shade 100% burning. Okay, then you just save it as JPEG file and then save. All right, so it will ask you whether you want to change the setting. You just put OK. So, all right, it must have a minimum size of 100 times 100, maximum of 20,000 to 10,000. So I think it's too big already. So maybe you will need to reduce it. Let's say I put it 20%. Okay, see whether I can export it or not. So when I export, try to put network. Okay, save. It's still too big. All right, so maybe I put it 38. Okay, make it smaller. So let's try to export it once again. Okay, save it. Oh, it is still too big. Okay, let me put it as 50. Maybe we can export it. Okay. Maybe I change the color. Let me change the color, and then okay, it still cannot. Maybe it's too small, too big. All right. So just to tell you that you can export it. So on the impact assessment, so these are the things. All right. Actually, I also can export this right from here. If you want to export this, you can actually export. Okay, so now that is how you do your analysis. So let's say if I want to do analysis on the assembly part only. If you want to do analysis on the assembly part, you should not come to life cycle. You should just go to assembly. Okay, in assembly, simple wood assembly. So I just click on it. Okay, so you will do a analysis. Now, just now we choose a single issue which focus on carbon footprint. Now let's choose a multiple issue. Let's say I choose something that on global recipe, we choose midpoint. All right, let's choose midpoint. So on the midpoint, I choose this midpoint H. So let's see. Now do a calculate. It may take a little bit of time. So we just wait. It seems faster than the network, and also when you are comparing three processes or three life cycle. Now I'm analyzing only one life cycle, so it may take shorter time. So when we are doing assessment analysis, so it is also very important for us to interpret. We want to understand what it tells. Okay, so now the result comes out already. So in the assembly, there are three main parts where the dark green represent plank, the light green represent the steel wire rod, which is the nail, and then the orange color represent the transport passengers. So remember, because we are analyzing the assembly, so the waste disposal is not included. Okay, so in this case, the method that we choose is recipe midpoint. So in recipe, there are more than 10 impact categories that they include: global warming, then ionizing radiation, ozone formation, and all these others impact categories, which include marine ecosystem, human carcinogenic, and many, many more. So in this case, we can, in characterization, like in the class I have explained, here I couldn't compare across impact category. I can only look at one single impact category, example, global warming, and I can tell you that from the global warming point of view, the production of plank, okay, contribute more than 65%. And then from steel is about 30%, and then for transportation is very little. Okay, so for freshwater eutrophication, okay, for production of steel contribute the most in this impact category, while transportation contribute the least, something like that. So in characterization, you can only compare within single impact categories. If let's say we do a normalization, then we can compare across. So in this graph, it shows us that from the assembly of the simple sheet, marine ecotoxicity is the main impact categories that is produced. Okay, followed by freshwater ecotoxicity, and then followed by human non-carcinogenic, and then the rest are rather, we call it not very much significant as compared to these three. So in here, so this is the main hotspot of your life cycle is the production of plank, all right, which contribute the most to marine ecotoxicity. So if this is show you in chart, you can actually require the software to show you in number. So in number, you can see the total is this much, which is already normalized, so there's no unit. So these are the magnitude. If you choose on characterization, so it will give you the unit and also the total and plank and three different assemblies, all right? Okay, now you can export this table as well. So to export this table, let's say I want to export this characterization table. So I open this page, so I just go to file and export it. So normally they'll export it in Excel format. So let's say characterization. Okay, so I just save it. So once I got it, I open and see what it is. How does it look like? Okay, so in this case, I'm opening the spreadsheet that I got. So I export this out, so you can do your own graph and chart and interpretation and manipulation. So for me, I prefer exporting the result in numbers out into spreadsheet, and then I'll do my own chart. Okay, so because I can do a lot of interpretation, discussion from there, right? So these are the things, just like you export your bank account statement. So export it into Excel, and then you can do your own accounting, yearly accounting, something like that. All right. So that's it for the analysis of this. Okay. So if you do one, you just close it. So like I say, you can also analyze single process. If you want to analyze single process, so you just go to the process. Let's say I would like to analyze felt tree. Okay, if you want to analyze felt tree, you just click on the felt tree. Even though you are in the input output, you still can analyze it. Okay, let's try. So you try to analyze this felt tree, and you use midpoint recipe as well. So you calculate it. So when you are doing so, you are analyzing the single process of felt tree instead of the life cycle or the assembly. That's why I say Sigma Pro is so flexible that you can analyze at any stage of modeling that you want. All right. So this example I'm showing you that we can analyze the felt tree process, a simple process as felling a tree. Okay. All right, so in this case, you see that? So to a failed tree, there are a product and also the chain solving. So in this case, felling a tree is there's no much impact. 100% is from the chainsaw because we know that felling a tree, there is no emission required. Everything is under chainsaw. So when you have a normalized, so in chainsaw, this is the main category, something like that. Okay, all right. Lastly, I would like to show you another with avoided product. Okay, so the avoided product is on the landfill there one. Okay, so you still remember that they can avoid the natural gas. So let's look at that one. So in this case, there is an output that avoided. Let's analyze, see what we can, the result, what result we can get from it. Okay, so if you look at this result, all right, you will be surprised that previously all results are showing you positive chart, right? So in this case, they're showing you negative chart. So something that coming down, all right? Or in value, it show you negative number. Do you see that? It show you negative number, all right? So in CIMA Pro chart, okay, positive means impact, means no good. Positive chart, okay, means no good. Negative value means benefit. So in this case, you will see that this is a benefit to the environment. So anything with a negative value means benefit to the environment. So the logic is this: the higher the positive value, the more impact to the environment. That's what we call life cycle impact assessment. Okay, the higher the value, positive value, the more impact to the environment. Means you can see the higher this bar, the more impact here. The lower this bar, the lesser impact is. When it comes to the negative value, the higher the negative value, the bigger the benefit to the environment. So this is better than fresh water. Okay, so this is better because it is longer, it is uh, bigger in magnitude. So it's negative. More negative means more benefit. All right, so this is how, that's the purpose I want to show you. So whenever you get a result, you know how to interpret it. Okay, all right, so that's it for today. So this is the video for the last one, 2.4, when we put everything in life cycle stages, and then we try to analyze it by choosing the suitable method according to your objective. All right, so that's all for today. Thank you very much.